We're making a space game, and space is, well, black. But flat black is boring. So, let's add a background to our game. First, let's begin by deactivating our player game object. It will simply be in the way for now. Next, create a quad to hold our background image by selecting Create, Quad, from the Hierarchy's Create menu. Rename this Background. Where is it? We've created a quad, but we can't see it in our game. Let's switch to the scene view to see what's going on. There it is. It's oriented in a way that's not facing the main camera. The main camera can't see it. To adjust this, let's first reset the game object's transform to make sure it is at origin, and then let's change the background's transform rotation along the x-axis. Let's set this value to 90 degrees. Now the background quad is facing towards our main camera, and we can see it now in the game view. I'm going to switch back to the scene view. The stock quad comes with a component we don't need. We can safely remove the Mesh Collider component as we won't be using it. Next, let's add a texture to this background. In Assets, there is a directory called Textures. Inside Textures, we will find an image, Tile Nebula Green. Let's select this image. When we select an image and inspect it, we are looking at that image's importer. We will leave the importer settings as they are. But if the preview window is open, we can see some additional information about this image. If the preview window is collapsed, we can drag the bar titled Preview upwards until we see the image clearly. The information at the bottom of the preview window tells us the current resolution of the image in our project, the current compression method, if any, and the total size of the imported image. What is important for us to note here is that this is a very large image, 1024 by 2048. So this image is more than large enough to stretch behind our 600 by 900 game view. This is also telling us that the image is not square, but rectangular. There are a number of ways that we can get a texture onto a mesh. Let's try one of the most simple ways. Grab the image, drag it, and drop it on the background quad in the scene. Done! Let's get a better view of our background. Use Frame Selected to focus the scene view camera. The image has been applied to the background quad. It's dark and squashed, but it's there. What just happened? We can see that the texture has been attached to a material, and the material has been associated with the quad by a reference in the mesh renderer. Our mesh filter holds the mesh data, in this case, the quad. The mesh renderer renders that mesh using the materials in the mesh renderer's materials array. The renderer is only able to use a texture if it's part of a material. We did not create a material, we simply dragged the texture onto the quad. It was Unity that created the material for us. When we drag a texture onto a mesh, if Unity cannot find an associated material with that texture, Unity will create a new material for us. Then Unity will automatically add that material to that mesh renderer's materials array. This automatic material will always be created with a default diffuse shader. Let's look at our background. Is it ready to go? No. It's small, square, squashed, a bit dark, and a little hard to see. The first thing we need to do is scale up our quad to fit our background. We can do this by changing the transform's scale properties. The quad is a very simple two-dimensional plane. We can scale the quad along the x and y axis, but not along the z axis. Trying to scale the z-axis does nothing. Let's reset the scale now that we've played with it. What scale should we use? Let's first look at the texture itself. It's 1024 by 2048. To keep the image undistorted when we scale it up, we should keep an aspect ratio of 1:2. This means our x scale should always be half of our y scale. Or conversely, our y scale must always be twice our x. To see this properly in the game, let's switch back to the game view. In the game view, select the background quad and scale it along the x-axis until it fills the screen. It's more than filling the screen when we use a scale value of 12 or more. We have enough resolution that we can afford to lose some of the image off the sides. So let's pick a good round number, like 15. It's more than big enough, so that we can maintain our 1:2 aspect ratio. What is 15 times 2? 30. If we have 15 in our x, we need 30 in our y. Now the background fills the game view with no distortion. Let's look at it in the scene view. Use Frame Selected to focus the scene view camera to the background's new size, and we can see that we now have a nice big background. The background is still a bit too dark. The material is using a simple diffuse shader. This means that the texture is being treated like a simple painted surface, using matte, not glossy, paint. The surface of our background is being lit by the lights in our scene. These lights have been set up to light our player's ship. One light, the rim light, is shining up from below and won't light the surface of the background at all. The other two have very shallow angles that only rake the surface of the quad, so our background isn't receiving very much light from our lighting rig. This is great for our player's ship, but not so great for our background. We could add a light shining straight down to light the background, but this would add another light to the ship, lighting it in a way that we wouldn't want. We could put the background and its new light on a separate layer, so that our background light did not mix with our existing lights on the player's ship. But there is a better way. For more information on layers and how to use them, see the information linked below. If we think about our background image, we simply want to have it display behind our game. It's a flat plane, we do not need specialized lighting like we need for our ship, and it's a waste to shine a directional light on a simple quad just to flat light its contents. When dealing with a material, how that material treats the texture depends upon what shader we choose. Diffuse treats the texture like matte paint. The specular shader will treat that texture like glossy paint or shiny plastic. There are many other built-in shaders that come with Unity. More can be found on the Asset Store, and we can write our own custom shaders. For more information on shaders, see the information linked below. For our purposes, we don't need any specialized lighting on our background. As a matter of fact, we don't need any lighting at all. For our background, let's change the shader. Let's choose Unlit Texture for the shader on our nebula material. Now our background is independent of our lighting system, and it displays the texture exactly as it looks in the original image, and it uses no lights at all. In the game, it's nice and bright. If we change the shader back to diffuse, we can see how much darker it is in the game. Let's bring back our player and check that everything looks good in context now that we have a background in place. Okay, something's wrong with our ship. Let's look at it in the scene view to see what's going on. The player's ship is buried in the middle of the background. They are both at origin. The background should be behind the game. So let's grab the background and adjust it along the y-axis. We can slide it into a good position by hand, or we can simply set the transform position on the y-axis to -10. Now the background is down and out of the way. When we look back at the game, we can't see any change to the background, except for the fact that it is no longer in the middle of our spaceship. This is due to the fact that our camera is orthographic and has no perspective. The background can be any distance from the camera as long as it's within its clipping plane and still look exactly the same. We have now set up our background and our lighting. Next, let's begin to create gameplay elements by moving the player's ship.